Good afternoon, everybody. Welcome to Inforce. My name is Vinod Madabushi. I'm an enterprise solutions architect with AWS. I've been with AWS for about 4 years, but I've worked with Microsoft technology and Active Directory for over 15 years. So today we're going to talk about deploying critical Microsoft Windows workload at Capital One. I also have Kenny Hill, who's the distinguished engineer with the Identity and Access Management team at Capital One. He's going to talk about some of his journey through the Windows and Active Directory specifically as well. Okay, so let's look at the agenda. So first we're going to start with why running Windows workload on AWS, and we're briefly going to talk about AWS Managed AD. We're going to talk about some of the features, security and compliance with the Managed AD, and then I'm going to turn it over to Kenny Hill, who's going to talk about security best practices and how Capital One went through their cloud journey in terms of identity and access management, also their journey through Active Directory and how they evolved over the last few years to get to where they were. At the end of the session, we'll have some time for Q&A, probably off the stage, depending on how much time we spend here. But if you guys have any questions, please save them. We can talk about it at the end of the session. We have a couple of related breakouts for folks who are interested in identity and or Active Directory. There's a couple of sessions that are upcoming today. So if you're interested, you don't have anything else going on during that time, feel free to stop by. Okay, so with that being said, why don't we get started here? So why is AWS one of the best places to run Windows workloads? So AWS have been doing the cloud since 2006, almost 13 years ago. And we have one of the deepest and the broadest service and platform in this industry. That's one of the big reasons why almost 60% of all Windows workloads that run in a cloud run on AWS. So when we talk about Microsoft workloads and the cloud, it's hard to talk about that without Active Directory, which is the center of identity and authentication. So AWS has a product called AWS Managed Microsoft AD, which is actually built out of real Microsoft AD, but it's fully managed by us. So you don't have to go through the pain of managing the domain controllers, replication, backups, snapshot, and so on. We do all of that work for you, and you can just utilize that AD to support any workloads you have. So not only that, it's also one of the only managed AD that preserves real Active Directory experience that you're used to in your own data centers. For example, setting up one-way or two-way trust between AWS Managed AD and your on-premises domains. Using native Microsoft tools like Active Directory users and computers and GPMC to manage your Active Directory on AWS. So we provide all of this functionality. It also has one of the richest features in terms of how it integrates with other AWS services, specifically Windows-related services. For example, RDS SQL Server or FSX for file server for Windows. Also, single sign-on. So it has native integration with a lot of these AD-aware applications within AWS. So let's look at how customers are deploying and using Managed AD on AWS. So one of the first use cases we're going to talk about today is what we call user domain. So this is a deployment model where customers are deploying Managed AD on AWS and keeping the user identities in those Managed ADs. So this is where your user accounts and passwords and all that sit. And from that point on, they utilize that repository for applications within AWS that are AD aware, for example, Windows workload, SharePoint server, SQL availability groups, and so on and so forth. And also they can federate those identities to other applications using SAML federation, right? Like for example, Office 365, Salesforce, or any other business applications you have. So you probably see a lot of applications here on your screen here. So these are all applications that support tight integration with Managed AD. EC2, for example, you can seamlessly domain join an EC2 instance to a Managed AD. RDS for SQL Server supports integrated authentication directly with Managed AD. We also have other applications like Workspaces, FSX, and Chime. They all have native integration with Managed AD. And this is one of the ways customers are using Managed AD in AWS today. The other way that's really popular with customers is what we call resource domain. So in this architecture, customers can still manage their on-premises Active Directory, still have the identities there and continue to have that as a single source of truth. But they will also use a managed AD on AWS to support everything they're doing on AWS. And they can do this with a one or two-way trust between Active Directory on premises and managed AD. And using that trust, they can utilize the same usernames and credentials that are on premises in AWS services. So again, if you talk about the services and integration, you can use all of the services that you can use with managed AD, but now you can extend that use to on premises. This fashion of using this managed AD is called resource domain. You guys may already be familiar with it. And the reason for that is you have the primary resources on the managed AD, but you still maintain the user identities on premises. One thing to note here is there's a couple of services here. RDS SQL Server, for example, the integration with managed AD is limited to being in the same account. What that means is if your AD is in a different account than RDS SQL Server, then you can no longer integrate that. But the great news there is there's a private preview for that feature we have going on right now that Capital One is extensively using that allows managed AD to be extended across accounts and still use them for RDS. And Kenny is going to talk about that in a lot more detail. Shared responsibility. How many of you know what shared responsibility model is? Okay, that's a pretty good number. So just to summarize in one statement, shared responsibility is where you can think of this as security of the cloud and security in the cloud. So AWS is responsible for security of the cloud, and customers like yourself are responsible for security in the cloud. So with respect to managed AD, how does this translate? So this is basically a grid of different tasks and who's responsible for what. So if you look on the left, basic things like protecting the hardware, software, networking layer on AD that runs on EC2, AWS is responsible for those. We're also responsible for isolating customers between each other, and we do that because the AD is a single tenant solution. We don't share data between customers. We are also responsible for patching the domain controllers with regular patches, security updates as Microsoft releases them monthly. Also encryption of EBS volumes, including snapshotting and protecting those snapshots. In addition to that, we're also responsible for maintaining and managing the domain admin credentials and fixing AD replication and managing to make sure the replication works seamlessly all the time. As a user of the managed AD, you're responsible for data within the managed AD. So you're responsible for creating users, groups, OUs, managing them, managing the credentials. If you're doing any schema updates, making sure you bring in a compatible LDIF, configuring security groups and networking so the managed AD can be reachable from all of your Windows workloads. Also, if you want to integrate it with MFA or other third-party software, setting all those up is your responsibility. So this is kind of how we think about when you're running managed AD on how both of the delineation works in terms of responsibility. Compliance. So you're probably wondering about compliance. A lot of you have workload that needs to meet certain compliance criteria. It could be FedRAMP, it could be PCI, it could be HIPAA. So you're wondering whether you can use managed AD and how the compliance would work in those situations. So these are some of the certifications that managed AD has. There's more certifications than this, but these are some of the key certifications that most customers ask for. So if you're using managed AD in a solution and you want that to be PCI compliant or HIPAA compliant or FedRAMP compliant, you can absolutely do so with managed AD. So the managed AD itself has the certifications, and then when you architect around that, you would still be responsible for other pieces of the architecture that you deploy, but the managed AD certification is already there. Okay, so with that, I'd like to invite Kenny Hill. He's going to continue and talk about the rest of the Capital One journey.
Thank you, Vinod.
Thanks, Kenny.
How you guys doing? My name is Kenny Hill. I'm with Capital One. I'm in the Identity and Access Management org. My main focus is directories with an emphasis on the cloud. By a show of hands, how many of you guys are using Managed Active Directory? All right, that's a few. How many of you are running your own Active Directory domain controllers on EC2? Bit more. How many of you are currently or plan to send all your Active Directory traffic back to on-premise? A few, a small amount. Okay, cool. We're going to talk about all of that. So at Capital One, the majority of our Active Directory infrastructure is running on AWS. We use Managed Active Directory, and we have a large number of our enterprise domain controllers running on EC2. It was pretty cool to hear Vinod talk about RDS SQL cross-account. So we'll talk a little bit about some of the big gains we've seen at Capital One with that. In the rest of the session, I'll start by sharing some general AD security practices we follow. It's not in a full list, no matter if Active Directory where it resides. I'll then share a bit about what we've learned over the last few years, where we can do better and be more secure. Hopefully you take away something in this session that you can put into your design or current deployment. There should be time at the end for questions. If not, or you don't have any now, feel free to connect. I love talking about this stuff. I'm not going to stand here and pretend to have the secret sauce for protecting Active Directory. There are many security folks probably sitting in front of me that are going to be more skilled at securing Active Directory. What I will say is anything new, any new solutions, the first thing I think about is security, very quickly followed by how can I do that better on cloud computing or with cloud compute services. Active Directory is becoming more and more difficult to secure. Simple internet search by almost a non-technical person, and if they're on your network and you have vulnerabilities, they can identify them. They can use copy and paste code from the internet and kind of wreak havoc. Beyond anything I mentioned, my best advice is stay very up to date on Active Directory security vulnerabilities and credential compromise techniques. A few things we do. Multi-factor authenticate anything and everything we possibly can. Web URLs are easy. Domain controller interactive logon. Protecting the WinRM, that type stuff's a little more difficult. It is possible. Any kind of bastion host, any kind of logons, multi-factor. Vault and rotate privileged in service account passwords frequently. Service accounts are a little more difficult in the cloud, and I'll argue with application teams that if they're able to rebuild their infrastructure in like a blue-green, then they should be able to utilize new credentials. So push the teams into more service accounts so they can have the password rotate. There should not be any reasons for old service account passwords out there. Follow the AD administration tier model. If you're not familiar, it's tier 0 where you have domain controllers, the infrastructure that supports the domain controllers. I'll jump down to tier 2 is where you have laptops, phones, printers, mobile devices, anything that a person can touch and put their hands on. Those are the risks, really. And then tier 1 is where you have all your application servers, your member servers, Linux, Windows. Those are really what you're trying to protect. The concept is to prevent vertical movement. No always access for highly privileged accounts. So if a credential was compromised, it's no good if it doesn't have access. So should your domain admin groups even have members in them or many members in them at all? Administrators, enterprise, any of the really SD prop, admin, SD holder protected built-in groups. Do they need to have members? So isolated tier 0 management with authentication silo, bastion host or privileged access workstations or both. So the concept here is your source machine that is going to be able to do management tasks on your domain controllers is the only thing that can connect on those ports. So you're not allowing access to domain controllers for WinRM, for RDP or anything except from essential tunnel. Monitor all logs, use cloud streaming and big data capabilities to enrich the logs and gain a deeper view. What we've seen at Capital One is we're able to see new lenses into Active Directory we've never seen before. So working closely with our cloud engineering data team, they take the VPC flow logs, they enrich them with tag data from AWS, and then they further enrich our like LDAP load balancer logs. So we can see, on premise you could see the IP address. Now we can see every application by name coming at our LDAP, coming at our Active Directory, and how they're using it. So if an application, you know it connects to LDAP like once a day, so it's most likely downloading some kind, groups for authorization, and you start seeing it hit 80 times an hour or a minute, you know maybe we should look at that. Also, make sure event logs are being created and not disabled. So many times companies are going to rely on their SIEM receiving event logs from domain controllers. Is everybody ensuring that they're getting the logs? So, or the logs haven't come in 5 minutes. Are you taking action? So if I'm a bad guy and I get on a domain controller, besides disabling any services you have running on there, I'm going to disable the event logs fairly quickly. Monitor state. By this, I mean, you know what your domain controller should look like, so constantly check state. So have a config file sitting in a repository of every registry hardening setting, any kind of, if you have an MFA service, any kind of services running. So constantly compare state. Active Directory is 20 years old, and about 80% of our large enterprises are still dependent in some form. Migrating to the cloud is a major transformation. Migrating to the cloud without Active Directory is completely possible, and it's also going to add a few years to your whole migration and transformation. I've spoken to many companies who are ready to move all their application systems into public cloud and are still hesitant to move their directories. It's fair in this day and age. When you read in the news about breaches, Active Directory is one of the crown jewels that bad guys go after. I do love conversations like this, so feel free to ask me questions around it. We initially tried to send all of our Active Directory traffic down to on-premise via Direct Connect. AD latency quickly became a bottleneck for us. Applications were not scaling at the speed we needed them to. Domain joins, any kind of logons were taking a long time. And there's also that risk of losing network. Fast forward a couple years, we found we're getting more security running our domain controllers on AWS. We rebuild what we call rehydrate all EC2s every 45 to 60 days with the latest AMI. This allows us to not have to worry about patching, and we're just checking AMI versions to know if EC2s have everything we want installed, all the security patches. Domain controllers are no exception to this. The sheer number of domain controllers that we're having to rehydrate, we are all for using AWS Managed AD where possible versus having to patch systems. We'd rather be enhancing our directory API or working on machine learning models against domain controllers, logs. I mentioned our directory API, which I'm not going to really dig into today, besides saying we see our directory API and managed ADs as abstraction layers around our central directory, taking away some of the dependency directly on our directory. With that, let's dive into Capital One's cloud journey. Active Directory cloud journey. There's lots of journeys. I already mentioned we originally attempted to use Direct Connect and come on-premise. At the time, AD Connector, which we do use in a limited form today for the time being, could not handle the number of objects. AD Connector, if you are familiar with it, it does handle the number of objects. It's just limited on how many of the proxy servers you're going to have. Another thing to call out in the on-premise model is you pin network connectivity as a single point of failure. If you're running a hybrid on-premise cloud and you're running in AWS public cloud, you probably aren't going to have that issue. But if you're just running your domain controllers on-premise and you're putting all your applications in AWS, you will lose that network connectivity at some point in time. It just happens. So just have a game day plan for what you'll do when that occurs. Ready or not, we start building domain controllers on EC2 and completely changing our vocabulary to speak cloud computing. Mostly automated, not even fully CI/CD. Pipeline at the time, we were still seeing some major gains. So we could add capacity by adding more domain controllers at rates we'd never seen before, and we could add actual instance capacity by shutting down instances and boosting up the hardware underneath of it when needed. We then learned a new cloud computing term called peer and route limits. We moved all of our domain controllers into a shared horizontal services account. Spoiler alert, don't do this. There are better options available today. The peer and route limit issue just wouldn't go away. So we deployed more AD VPCs with more domain controllers to peer to the new lines of business accounts. The concept here is you have an AD site for each AD VPC. You have the whole CIDR range added as a subnet to that in Active Directory. Then each line of business VPC CIDR will be added to the AD site. What this does is this allows or ensures that any communication using DC locator process will go over the peer to the domain controllers you want. Well, we also started wanting to use enterprise credentials and access groups for RDS SQL. So to migrate quickly to the cloud, you're going to take some of those relational databases, like it or not, and many applications are dependent on SQL. So Managed AD makes sense. So then you're ensuring that you're using your central domain credentials for that. RDS SQL, as Vinod already mentioned, required Managed AD to be in the same VPC as the database. This also started adding a large number of infrastructure, more than we wanted. At least we weren't managing those EC2s behind the domains. Fast forward to sometime last year, AWS increased both the peer and route table limits. This allowed us to consolidate down from 4 Active Directory VPCs in our busiest regions to 2. 1 for production, 1 for non-production. Repeering all of the line of business VPCs and updating the AD sites was not a fun task, and the team who did it did an awesome job. They called no major service issues, so hats off to them. Decreasing the complexity and dividing the AD VPCs by environment, production and non-production, is also allowing us to centralize our Managed AD. This adds the additional security to our AD infrastructure by isolating all Active Directory into a single AWS account. Another benefit is we're less likely to hit service limits and can more easily throttle consumption of certain services. Also opens up options to disable services. For example, we can block via IAM role any snapshots from being taken inside the account to permit intentional or unintentional creation of a DIT file. So concept here is somebody gains access to your AWS account, they snap a volume off a domain controller, they take that snapshot, they attach it to a Linux, they extract your database, run Mimikatz, run against a rainbow table or 12 other things you can look on the internet for and find out. And you guys know how that story ends. Hopefully you've read. Owning the account and controlling who has access to the account service gives us way more control of how, when, and who receives access. The read-only role I'm showing is both what AD support engineers and development software engineers have always on. They can read and view enabled services and open support tickets with Amazon. Even with the read-only role, we still want to ensure we're getting that MFA. So we're still getting the multi-factor authentication even to come in and see anything. We want all changes going through pipeline. That is great to say, and not always 100% the reality. A time will come, a person needs access to make a change, resolve an incident, or there is an AWS service which API functionality hasn't been released yet. Concept here is giving the engineer the ability to escalate to an elevated engineer for a temp period of time. There are many ways to do the just-in-time portion of it. You can use PIM, you can use sunset capabilities, you can build your own. There's a handful. There's other products too. The concept is short-lived, in this model, is short-lived access into an Active Directory role group attached to the AWS IMR. Even before the just-in-time group occurs, we also want to validate there is a change control or an incident. It is assigned to the tech who is requesting the elevation, and this is the one some people don't have in their logic. The time that that change or that incident is set to be is the only amount of time that credential is given the just-in-time access. And it's approved, and approved by somebody other than the person requesting it. This is our ideal state for changes. Engineer does a pull request to a repository, a peer approves, the change is checked for and scanned for security vulnerabilities, both functional and unit testing is happening in a downstream environment, and a change is automatically opened and approved. Deployment occurs via pipeline, and any credential that is needed is pulled from a vault, so no person needs it. The key thing here, though, is no person direct access to AWS platform. This takes a while to get to for an application team and requires a solid software engineering skill set. So to do this correctly, most Active Directory engineers who've been around for 20 years are going to need help of some either mid-stack or full-stack software engineers. Above is depicting our original model of Managed AD to support AWS RDS. We are beginning to move more towards an AWS account per application, and this could put us at the risk of hitting AD trust forest limits. So we utilize a one-way forest trust. I'll show it in a minute. I think the last time I checked, I think it was many years ago, but I think it's like 2,400 trusts you can create per forest. But if you have production, you have non-production, you're in multiple regions, you're doing a isolated managed AD per region to keep your blast radius down, you could feasibly hit 2,400 pretty easily. To create a forest trust, Managed AD needs to communicate with the PDC emulator role holder to create the TDO objects. We currently have our FSMA roles sitting on premise across a couple sites. Our Managed AD security group, which is created by default when you deploy the service, needed to have a large CIDR range to cover multiple on-premise data centers. You also want to ensure, because you could have an issue and you need to move your FSMA roles. It's not a big deal to move them, but you need to have that IP range covered. So you can see in the above, we have connectivity from our lines of business account to our AD application account for authentication and authorization. We then have domain controller connectivity for replication and those type things to on-premise. We then also had to have connectivity from the lines of business account to our on-premise for the Forest Trust. You can also see that in the lines of business accounts, the Managed AD security group is there. Each application we have goes through a compliance review for their specific AWS security group, ensuring that really they only have the connectivity they need, and it's mostly their application to their subsets. So the application can talk database and nothing else they need. With the large CIDR ranges we have in Managed AD security groups, we have found that even just for troubleshooting purposes, other teams have borrowed our groups and to add to their EC2s, RDS, and it's fair. People are going to do what they need to resolve an incident. And oftentimes they're going to go back to bed and they're going to forget to clean up. So we've had to create rules in our cloud custodian to monitor this, and this has increased our operational tail and created more work. Last year, AWS released the functionality to share managed Active Directory cross account. So no longer per VPC, full from account to account. This was initially only released for EC2. What you heard from Vinod is that we've been in a private preview for RDS cross-account. For us, this is huge. As you can see in the diagram, this allows us to move more towards a managed AD inside of our lockdown Active Directory account, share the managed AD out to other accounts, simplifies infrastructure, decreases costs, and reduces risk. As you see, the security group that was there is no longer there. We then no longer need the traffic back to on-premise, and allows us to better monitor our applications consuming anything on-premise to help us accelerate our journey into the cloud, ensuring no on-premise dependencies. What I'm showing here is a high level of our Active Directory footprint in AWS. We have our lines of business accounts, which are moving more towards the shared managed AD. There's also need for connectivity usage of our AD and our AD application account for like LDAP. We have our AWS AD account where we have our central managed AD. We have our domain controllers running on EC2. We have an LDAP load balancer, and then we also host our directory API there, and then many other lambdas for tooling or other kind of data pools and stuff. Inside the secure cloud management account, we have automation for deploying the managed ADs. We created this a few years ago. We still maintain it and keep it in place in case we need to be able to deploy a managed AD for either a DR exercise, or we just want to spin one up for testing and stuff. So we decided not to decommission that. Finally, we have our network connectivity in on-premise. We also have a small footprint elsewhere. A huge requirement for us is to manage our own identities. Keeping our identity central gives us the flexibility of treating our enterprise directory as a hub for services. You can see in the diagram above, we took the approach of treating managed AD as a resource forest with a one-way forest trust to our enterprise AD. As we already had domain controllers running in AWS, the hope was we were able to decrease some of our domain controllers running there. In this model, we still use our corporate credentials for authentication and our AD groups tied into our provisioning system for authorization and access. All user authentication will be sent from the managed AD to the enterprise directory, while computer authentication, GPO processing, and that stuff will be sent to the managed AD. So this also allows you to decrease the network traffic that you need to monitor going to your central enterprise directory. AWS does delegate the capability to rename the default site name. If you're going to go with a forest model where you're going to do a trust, you want to do this. This is going to ensure that the traffic coming from anything joined to managed AD or consuming managed AD will go on the most optimal route to the domain controllers in the AD site that you define. So you want the site names to match in managed AD and match in your enterprise directory. Many of you may be familiar with selective authentication. If not, setting up selective authentication on a trust allows you to control which users will be allowed to authenticate to resources no matter what the resource ACL states. When you're fully mature in the cloud, really users should never directly be logging into systems. With that said, it's a very long transformation to get there, and there will always be exceptions. It's difficult to prevent people from calling commands inside their user data that will add undesired accounts, at least for policy, to administrators. For the most part, you should only need to allow system or service accounts and maybe a small subset of privileged accounts to actually transverse the trust. You can then apply stronger password rotation and complexity to those accounts you allowed to transverse the trust and ensure that the credentials are vaulted and passwords rotated. You can deny most regular users. If you're setting up workspaces or FSX or other end user managed AD compatible services, you can then create a whole separate OU in managed AD and apply allow to authenticate with a separate group or to that OU. So ideally, you can say that someone using Workspaces is allowed to log into Workspaces with a regular credential, but that same account cannot log into a member directly to a server sitting in another OU. In the resource model with selective authentication, you have both the local access control list. So in this diagram, local access control list is like local administrators group or an NTFS, on a share, the security on a share. And you have selective authentication. So this is essentially doubling the access checks and allows you to build into your provisioning system which accounts can authenticate across the trust. So you can have multiple groups tied to your provisioning system and then build in the rules inside the provisioning system that say this type of account or this is allowed to utilize resources. Typical on-premise Windows local administrator processes do not work. They don't really apply to the cloud. Active Directory GPO restricted groups is not the most efficient in the cloud, and I'll argue with anyone that they're not the most efficient on-premise either. They apply one group to all servers, and so they created bloated groups with usually end up being a shared admin model, which I don't think in this day and age we really believe in a shared admin model anymore. GPO group policy preferences based off of the computer name also don't really apply in the cloud. If you're using dynamic IPs, you're using dynamic host names, you're not going to know your computer name, but also somebody a second, 3 days, or a week ago could have had that same computer name. So tying those direct to AD groups doesn't really work. We utilize Laps. It's not our favorite solution, but we utilize it instead of AWS's built-in administrator account rotation. The reason for this is this gives us the ability to lock down inside the directory the access control list to the Laps passwords and then have a custom UI that we built out on checking out the credential. So we can validate and we have an audit trail of who was able to check that out, and we don't let anyone check it out unless it's a break glass scenario. So our ideal state is that anybody logging in as an administrator to anything is going to use their domain credentials. That way we have the domain logs also, and we only utilize local administrator on a Windows machine for a break glass scenario. We also use a variance of the computer name GPO preference. Instead of targeting, we target an attribute. I'll try to explain it. I don't know if this slide really is going to depict it that well, but all instances are domain joined prior to user data even running. So I don't know if it's still called EC2 service, but our team that takes the images, the AMIs from AWS, they give them some Capital One love, which I consider all of our security products, make sure that all of our, they're hardened and everything. They build in that the machines are going to domain join and user data is disabled until they domain join. If they don't domain join, then user data will never run. Teams who need admin rights assigned are required to make calls inside their user data and pass their application name. Prior to this, they were required to go to our provisioning system and onboard needing cloud admin for Windows. And this would create a group with a prefix, app name, suffix. Above shows the GPO preferences settings. Create a variable, do an LDAP query inside the GPO off the computer name, and pull back the attribute that you define for your app name. Take that variable and make it that app name your variable value. Next, empty all users and groups from local administrators. Then define, you have the naming standard, and then you apply the group that is built into the provisioning system. So only a group with the prefix and the suffix that you define in your GPO with the app name in the middle, or you can switch it around any which way, is going to be applied to the Windows servers. So no, this is not perfect. people could still add in their user data to create another local administrator account or to add groups. What this does, though, is this brings us back to state. So the GPO is going to run every 90 minutes with, I think, like a 30-minute offset. So at least every 2 hours, it's pulling back into state. So if somebody does something, they add a system account during their build and their application works, well, their application is going to stop working in 2 hours. So, and they'll keep doing that, and then they'll learn, okay, well, I need to follow the process. That, or if it keeps everything, keeps administrators, we know that in an ideal state, we're only going to have those groups added. All right, so logging. In short, storage is cheap. We all know that. Log everything. The capabilities of big data and query now available in the cloud really changed the game for views you can have with Active Directory and really anything. Alert on all activity inside the AWS account. So you want to know anyone who logs into your AWS account, if they're logging in elevated, if they're logging in read-only. You want to know if any S3 bucket policies change, any IAM roles have changed. You want to know if you have an Active Directory account, you really, besides maybe your Lambdas, you shouldn't have any Linux spinning up. If someone spins up a Linux, you should alert on that. Or if somebody's building Windows EC2s and it's not coming from, it wasn't the pipeline account, you should know that. You want to know it. Capture all the VPC flow logs. Capture all logs from enterprise domain controllers. Compare and alert on all IAM changes with expected state. So you should know your exact state and be able to keep a file in your repository of what all IAM is applied to your account. So if you see assume role show up, or if you see a new policy, even if it was planned and it was planned by a different team, you still want to know about that and you want to scrutinize, does that make sense for my account? Enable forwarding AWS Managed AD security logs to CloudWatch. Showing here is how to collect and forward the Managed AD security logs. One thing, no, Amazon has a blog post on how to do this exact model and send it to Splunk. So it includes a Lambda function template. So if you utilize whatever you use for your log aggregation, you can take that Lambda template and modify it fairly easily to send wherever you want it to. Above, we're showing some of the automation we put in place for Managed AD. Maybe we'll do a future session on the full pipeline of deploying enterprise domain controllers. The first one I already talked about earlier is the deploy Managed AD. So we're not really using this as much now that we have sharing feature, but we still want to keep it in place. The next is a new Lambda we created to be used during both the migration to from VPC Managed AD to shared Managed AD. This will also be used every time a new AWS account is created. It initiates a share to the line of business account, a share request, and then assumes a role inside of the line of business account to accept the share and update tags inside the Managed AD. So Managed AD, when you share it, it does create a new directory ID inside the account that it's shared. One thing to know, you can also do this with organizations. So this is called the handshake. You can do it with organizations, but you have to put your Managed AD in your root of your organizations. We view our root of our organizations kind of as our AWS IAM, keys to the kingdom. We consider domain controllers are keys to the kingdom for other things, so we don't want to merge the two and put them in the same account. So we utilize the handshake method. It's not that big a deal. We also have another health check Lambda we've put in place to constantly validate all Managed AD domain and all of the domain controllers are health. This function has some logic to add domain controllers. If it hits a specific criteria we've defined, we will add more Managed AD domain controllers. I think it's a soft limit of 20 and really infinite. If you just make a support ticket, they'll beef up your limits. We also have inside of this Lambda function the ability to open a support case. If we see a repetitive negative pattern we feel is occurring, we'll open a support case with Amazon. Amazon handles most of this for you, but it gives us, using platform as a service, this gives us a little bit more insurance that we have full faith in utilizing the service. We also have an unshare function. That we use before AWS account deletion. Because we're building in sharing a managed AD every time we build an account, so if we spin up a bunch of AWS accounts for a hackathon, or we're doing machine learning classes and they need isolated AWS accounts, you have to run the unshare. So part of the account decommission process would be to call this before you delete the AWS account. To recap, some of the benefits of AWS Managed AD are decreased operational overhead, continue to maintain authentication and authorization from our enterprise directory, speed and resiliency, increased security, API functionality for management. So I want to thank Vinod for taking time to help work on the slides and sharing the session with me. I also want to thank the AWS IAM Directory Service team for inviting me here to share a bit about our story, and more importantly, for their continuing to deliver features that help us meet the Capital One Active Directory roadmap. So everyone, thanks for listening. Love to connect after if you have questions, and both Vinod and I will stick around if you guys have questions.